Alright guys, today's goal, the learner will understand how to apply properties of logarithms. Okay, properties of logarithms. Let b, m, and n be positive numbers such that b cannot equal 1. The reason they have to be positive is you can't take the log of a negative number. Okay. The product property. The log base b of m times n equals log base b of m plus log base b of n. So if I had this, log base 2 of 3x, that would be log base 2 of 3 plus log base 2 of x. Okay? Quotient property. Log base b of m divided by n equals log base b of m minus log base b of n. So if I had log of 3 divided by x, that's log base 10 of 3 minus log base 10 of x. Because remember, if there's no base there, it's 10. Power property. Log base b of m to the n equals n log base b of m. So if I had log base 5 of x to the 4th, that's equal to 4 log base 5 of x. So let's take a look at some more examples and let's go through these. Use log base 6 of 5 is approximately 0.898 and log base 6 of 8 is approximately 1.161 to evaluate the logarithm. Okay, so I look what operation is going on in division, so I use the quotient property. So I'd say log base 6 of 5 minus log base 6 of 8. It's always the numerator minus the denominator, okay? So this would be 0.898 minus 1.161. So just go ahead and do that in your calculator. So this one they want me to evaluate. Log base 6 of 40. Well, your calculator only does log base 10, so I can't use the calculator. So I look up here. I have 5 and I have 8. Those are the ones I have. Well, how do I use 5 and 8 to equal 40? Well, 8 times 5 is 40, so I would change this to log base 6 of 8 times 5. And then you would say log base 6 of 8 plus log base 6 of 5 using the product property. And then that would be that would be 1.161 plus 0.898. Let's look at another example. Log base 6 of 64. Again, we didn't have 64, so we'd have to change this 5, no, because it doesn't end in a 5, so 8 only, well, 8 squared, so we could say log base 6 of 8 squared, which is equal to 2 times log base 6 of 8, which would be 2 times 1.161. Okay? So there's how we can use it when we're calculating things and they give you approximations. Now let's see how we can do it when they want us to expand or condense things down, okay? It says expand or condense the logarithms. Alright, well, I can't condense it anymore because log of 3x to the 4th is as condensed as it'll get. So that means I got to expand this one. So what operation is going on between 3 and the x to the 4th? Multiplication. So product property says I can change it to this. Now I look. Is there anything else going on in the first log? No. The second log, yes, because it has the power property. So I can change that to this. So, because remember, what you do is you take the exponent, you bring it down to the front. So see how I brought it down and changed it, instead of x to the 4th, it's 4 times the log of x. these properties also all work for natural log. So here, the same properties. And see, this one we're going to want to condense, because see how there's more than one? So what they want you to do is you need to end up with the natural log of one thing. So I look. Well, first thing I see here is you have the multiplication going on, so that means I need to move this back up. So I would say natural log of 4 plus the natural log of 3 to the third minus the natural log of 12. Well, that would be natural log of 4 plus the natural log of 27, because 3 to the third is 27, minus the natural log of 12. Now just go from left to right. So start here. Natural log of 4 plus the natural log of 27. Well, that's natural log of 4 times 27 minus the natural log of 12. And that would be the natural log of 108 minus the natural log of 12. And subtraction means we condense to division using the quotient property, so this would be the natural log of 108 divided by 12, which is the natural log of 9. Now your calculator, you can just hit natural log 9. So if you use your calculator here, now that's fine, this is what I want, but just to show you to calculate with the calculator, it would be 2.197. Okay? Alright, let's take a look at a little bit more. Alright, here we have the change of base formula. Logarithms with any base other than 10 or e can be written in terms of common or natural logarithms using the change of base formula. This allows you to evaluate any logarithm using a calculator. See, here's everyone's favorite. So, remember your calculator, you can only do natural log or you can only do base 10. So let's see. If a, b, and c are positive numbers with b not 1 and c not 1, then log base c of a equals log base b of a divided by log base b of c. Okay? In particular, log base c of a equals log a divided by log c, and log base c of a equals natural log of a divided by natural log of c. So what this is telling you is you can change it to any base, but for our calculator purposes, you either need to change it to log base 10 or natural log. Okay, so let's look at the first example here. It says, use change of base formula to evaluate the logarithm. So log base 5 of 8. So we're going to apply this right here. So a is 8, c is 5, so you have log 8 divided by the log of 5. So go ahead and put that into your calculator right now, because you should get approximately 1.292. This is the same thing. Hit right now, natural log of 8 divided by the natural log of 5. And it's going to be the same answer. That's what this means, is they're the same answer. So it doesn't matter which one you use. Okay? Let's take a look at one more. So log base 26 of 9. So that means natural log of 9 divided by natural log of 26, or log 9 divided by the log of 26, which is approximately 0.674. So there's some properties that we apply to logarithms and natural logarithms in order to be able to calculate better. So we'll see you guys tomorrow.